Okay, so for the next set of notes, we're doing a combination. Unlike yesterday, in a combination, labeling doesn't matter. So let's review. Set B, we say, is a subset of set A if each member of B is also a member of A. So if all the things that are in B are also things that are in A, then we say that B is a subset or a subgroup of group A. So once again, a subset is like a subgroup of a bigger group. And we say that you're a subgroup if all of your members happen to be members of the bigger group. An empty set is pretty much a subset of every set. Every set, we say that it has the empty set. So if I were to list all the two-letter subsets of the set JKLM, that's saying that you have a group of 4 letters, JKLM, and then you're just trying to make subgroups with 2 letters at a time. So I can have JK, JL, JM, and then once I do that, notice that there's when I write these down, I always start with the first letter, and then I go, okay, I'm going to partner you up with K, and then I'm going to partner you up with L, and then I'm going to partner you with M. And then I move on to K. K will be partnered with L. K will be partnered with M. And then last but not least, I do L with M. You'll notice that JK is a group, but I don't repeat KJ. Notice that JK only appears once. So it's like saying that in my class, or actually a group of Miss Knudsen and I is the same thing as a group with Miss, okay, Bueno and Knudsen in a group is the same thing as having Knudsen and Bueno in a group. So the order in which I say these things doesn't matter. We still belong to the same group. So that's pretty much what a combination is. And it's kind of funny because a combination lock, you would think that is a combination, but it's technically a combination lock is a permutation, because when you do your lock on your locker, you pretty much, the order in which you do the combination or that you put your number in, your password, matters. So yeah, combination locks, they're technically permutations because the order does matter. If you got confused, too bad. Ask an Eager. Okay, so once again, in a permutation, you have a big group of size n, and you're looking at the number of ways to group little groups of size r. But then you're also applying a distinct label. Another way to say label is you're arranging it. So anytime you think about arranging, labeling, ordering, you're dealing with a permutation. To me, it's easy to just remember a label. First, second, and third. Or, the password. What is your first, second, and third? Things like that. So anytime you have a label, you have a permutation. The formula for a permutation, we said, was going to be n factorial over n minus r factorial. In a combination, however, we are no longer worried about the order. So you still have a set or a group of size n, and you're still grouping r objects into groups, but labeling is no longer important. So in this case, we could have something like n choose r. It is very similar to a permutation, so you're still going to have n factorial over n minus r factorial. But because I don't care about the order, I'm not going to worry about double counting. So we're going to go ahead and divide out r factorial. What this does is it divides out the order. It gets rid of labels. So in a permutation, you would count JK and KJ, because one is first and one is second. In a combination, JK is enough. So it's kind of like saying the Knudsen Bueno idea. Or, yeah, Knudsen Bueno. So Knudsen and Bueno being in the same group is the same thing as Bueno and Knudsen being in the same group. So that's a combination. Knudsen Bueno would count as one combination. But if I'm talking about who first gets to school and then who then gets to school, so who's the first to get to school and who's the second to get to school, then if I were to say Knudsen Bueno, that's different from Bueno Knudsen. Knudsen Bueno would mean Knudsen gets here first and I get here second. Bueno Knudsen would mean I get here first and then Knudsen gets here second. So once again, in a permutation, your labeling matters. So the same letters can be written. In a combination, order doesn't matter. Alright, so it makes more sense once we do it. When we're evaluating 7 choose 4, it's going to be 7 factorial over 7 minus 4 is 3 factorial. That would make it a permutation. But because it's a combination, I'm going to go ahead and multiply by 4 factorial. Once again, 3 plus 4 is 7. Ooh, it's that pattern that you've seen before. So this ends up being 7 times 6 times 5 times 4 factorial over 3 factorial, 4 factorial. The 4 factorials cancel. 3 factorial is 3 times 2 times 1, which is 6. So this ends up being 35. When we have 10 choose 0, this would mean 10 factorial over 10 minus 0 factorial, which is 10, just like a permutation. But to make it a combination, you then have to add on that number, 0 factorial. Still, your answer is 1. And once again, you're just making groups or subgroups. So in this case, you have 10 people, and you're making groups of 0 people. The only way to do that is to not do anything at all. So I'm only going to group 0 of them, so one way to do that. As a reminder, 10 choose 0 is 1. The only way that you can group 0 people out of 10 is to not do it at all. 10 choose 1. If you have 1 person groups, the number of ways that you can get 1 person in a group is 10. You have 10 options. And then 10 choose 10. If I have 10 people and I decide to group all 10 of them, the only way for me to group all 10 of them is to just get them all. So you just choose all of them. There's only one way to do that. Okay? Alright. So now let's go ahead and apply it. How many combinations, keyword combinations, of the letters in the word absolute are there, taking the letters 3 at a time? So in this case, we have, well, how many letters do we have? 1, 2, 3, 4, 5, 6, 7, 8. I have 8 words, and out of the 8, I'm looking for how many combinations I can make, only picking 3 at a time. So this would be 8 choose 3. This would give us 8 factorial over 8 minus 3, which is 5 factorial, 3 factorial, which ends up being 56. Okay? This is different from having 8 times 7 times 6, because this implies that I am choosing someone first, choosing someone second, and choosing someone third. But in this example, I'm choosing all the letters at the same time. So I'm no longer doing first, second, and third. So it is not this. We are not labeling. I'm not taking 1 at a time. When I take 3 at a time, the order in which I take them doesn't matter. I'm no longer labeling them. In this example, it would be, this is the first option, my second option, my third option. So we accidentally label without meaning to. So once again, this is a combination because first it says it's a combination, but most importantly because you're taking the letters at 3 at a time. You don't care about taking one and then taking the next and then taking the last. Once again, for this on your calculator, you would go to the math button. Oh, first put the numbers. So in this case it would be 8. And then we go to math, probability, and this would be number 3. And I'm choosing 8 choose 3. And we usually say 8 choose 3. There's 56 ways. Alright, backside. Alright, on the back example, we have in how many ways can can a student select 6 courses from 7 electives and 5 core courses if 3 electives and 3 core courses must be taken? I know this is worded all weird. So pretty much what you have is you have a student who has 6 periods. You must select 6 of them, 6 courses. Out of the courses, how many ways can a student select 6 courses from 7 electives and 5 core courses if 3 electives and 3, yes. Okay, so yes. So you have to select 6 periods. Now, there's 7 electives that are available and 5 core courses that are available. Out of the 7 electives, 3 electives must be taken. So 3 electives must be taken from the 7 electives that are available. And 3 core courses must be taken from the 5 that are available. And together you'll have a schedule of 6 periods. Now the keyword here is also and. You have to choose this and that. You must have 6 periods. So the first thing we're going to do is we're going to talk about, well, I need to choose some electives, and I also need to select some core courses. The number of ways in which I can select electives would be, out of the 7, I'm going to choose 3 of them. Now remember, in this case, this is a combination, because if I were to have, for example, an elective would be art, a language, and I don't know, what else is an elective? Art, language, and let's say computers. If you have art, language, and computers, it is the same thing as if you have in your schedule computers, art, and whatever other one I just said. So the order in which you choose these electives doesn't matter. You're still going to have the same 3 in your schedule. For the core courses, out of the 5 core courses, I'm going to select 3. And once again, for the core courses, let's say you have math, science, and English. If you have math, science, and English, it is the same thing as if you have English, math, and science. You still have the same 3 classes. Now, it's up to you whether like, oh, the order in which I take them, yeah, that's cool. That would be how many schedules can you make. But in this case, it's all about how many courses are you taking, not the order in which you're taking them. So we have electives, and I have core courses, and this would equal 7 factorial over 7 minus 3 is 4. Don't forget the 3 factorial times 5 factorial over 2 factorial, 3 factorial. Because 5 minus 3 is 2. Okay, this would eventually be 350. Now something to also note, make sure that you know this. 7 choose 3 is the same thing as 7 choose 4. If I have 7 electives and I have to choose 3, it's the same thing as having 7 electives and not choosing 4. So they'll give you the same numbers. If you don't believe me, look in your calculator. So if I do 7 choose 3, I get 35 versus 7 choose 4, where I still get 35. And hopefully this should remind you of Pascal's triangle, where there was some sort of symmetry. We'll go over that later. Alright. So for the next example, from a standard deck of 52 cards, how many hands of 5 cards, all from the same suit, can be dealt? Okay, so let me show you a picture of cards. You have a deck of cards. In a deck of cards, we have black, clubs, and there's black cards and there's red cards. The black cards would be clubs and spades, and the red cards would be hearts and diamonds. You'll notice that there are 13 cards in each suit. So this would be your clubs. There's 13 cards. We consider these to be our face cards. You have 13 of each suit. There's 4 suits. And those 4 suits have 2 different colors, black and red. Okay. So in this case, it's saying how many hands of 5 cards, all from the same suit, can be dealt. So it's, for example, saying, let's say I pick the suit, this suit, the clubs. Out of the clubs, if I want a hand of 5 cards, then I can have 1, 2, 3, 4, 5. Or I can have 1, 2, 3, 4, 5. Or I can have 1, 2, 3, 4, 5. Or they can even be out of order. This one, 8, 10. You know, as long as you have 5. But the key thing is that they all have to be from the same suit. So I like to see this as tasks. A task is something you have to do, kind of like You're making yourself a list of things you got to do. So in this case, I have two tasks. I need to make sure that they're all from the same suit. Once I select the suit, so because I could have all spades, all 5 spades, or all 5 spades, or all 5 clubs, or all 5 hearts, or all 5 diamonds. So first I need to figure out, well, which suit am I in? So I need to select the suit first, and in that suit, then I need to count how many ways I can get 5 cards from that suit. So let's write that down. So you have 2 things to do. Task number 1. Let's go ahead and select the suit. We need to make sure that they are from the same suit. Once I have a suit, then in that suit, I need to select 5 cards. Select 5 cards from that suit you just picked. Okay. So I need to select suit and I need to select 5 cards. So suit and 5 cards in that suit. Okay. Well, I have to think about the suits as being how many total are there. Once again, a suit would be one of these. So you have 4 to choose from. You can have clubs, spades, hearts of diamonds. Out of the 4 suits, I want to choose just the 1. Once I select that suit, in that suit there are 13 cards. And out of those 13 cards, I need to choose 5 of them. Any order, it doesn't matter. And they don't have to be consecutive, it just has 5 cards. Notice that for both of these, it is a combination because we don't care about the order that they're in my hand. When you think about playing a game with cards, me having 1, 2, 3, 4, 5 is the same thing as me having 5, 4, 3, 2, 1. It's the same hand. You're not really changing anything. So it's a combination because the order of these cards does not matter. It's a grouping of these cards that we care about. Alright, if we do that, then the number of ways to choose a suit, 4 choose 1 is just 4. There's 4 possibilities. And I'm going to multiply that by 13 choose 5, which is 1,287. This ends up being 5,148. So once again, if you do 13 choose 5, that's just selecting 5 cards out of 1 suit. But because there are 4 suits, we have to multiply by 4. Almost done. Hang in there. Okay, for part B, how many hands of 5 cards can contain 3 aces and 2 kings? Well, in this case, you can clearly see the 2 things you have to do. Task number 1 is going to be to choose 3 aces. And task number 2 is going to be to choose 2 kings. So I'm going to need my aces and I'm going to need my kings. Well, for the aces, first you have to consider, out of the aces, what is the total number of aces you can have? And going back to this, there are 4 kind of aces I can have. So out of the 4, I'm going to choose 3 of them. Out of these 4, I want to choose 3. Now for kings, we have these kings. There's 4 of them. Out of the 4 kings, I want to choose 2 of them. And remember, it's a permutation because the order of the kings doesn't matter. It doesn't matter if I have a king of clubs and a king of spades versus a king of spades and a king of clubs. In a combination, the order doesn't matter. As long as they're both in there, you don't have to double count them. Okay, so in this case, this will be 4 choose 3 is 4 and 4 choose 2 is 6. You can also plug it into a calculator. There are 24 hands you can make. Okay? Alright. Part C. How many 5-card hands contain exactly 3 kings? Now this one's a little bit tricky because you need to actually get 5-card hands, like 5 cards total. But for sure, out of those 5 cards, 3 of them need to be kings. So my first task is to make sure that I have 3 kings. But that's not it. You don't just want to choose 3 kings. you still have 2 more cards that you need in order to get 5 cards total. So my next task is to choose 2 more cards. Choose 2 cards. However, if I select 3 kings, looking back at this picture, if I select 3 kings, then for the leftover cards, I don't have, you know how it's 52 cards total? 52 minus 3 is 49. However, I don't want to pick 2 cards from the 49 because what if I pick the last king I didn't already have? So in order to make sure that you get exactly 3 kings, you're going to choose 3 kings, and then from the non-kings, so ignoring all the kings, from everything else, you're going to select 2 more cards. But by ignoring the king you didn't select, by not including him, you don't run the chance of picking another king. Because remember, you want exactly 3 kings. Once again, 2 tasks. You have the kings, you want exactly 3, and then from whatever's not a king, you're going to get your other 2. So kings. We said there are 4 kings total, and I'm going to choose 3 of them. From everything else, so because there are 52 cards total, 52 take away 4, that would be 48. From the 48 other cards, I'm going to choose 2. Remember, 48 is the number of cards that are not kings. The most common mistake people make is they'll do 52 and they'll take away the 3 they already chose, leaving this one in there, or one of those kings in there. You want to make sure that out of the other 2 cards, you don't include any kings in your total. Okay, so this ends up being 4 times 1,128, which is 4,512 hands. Alright, and that's it. Good luck. Make sure you go back and you re-listen to everything if you need extra help.